Hey there, have you ever wondered exactly how a computer program actually makes choices? Well, in this explainer, we're diving into the source material to master Python conditional statements. We'll be walking through a worked example that reveals the step-by-step logic path a program takes whenever it encounters a fork in the road. Let's get into it. So think about it for a second. How does Python actually decide what to do next? Honestly, it helps to picture Python as a master detective trying to crack a case. You know, when a detective hits a crossroads, they rely on a really specific logic process: claim, evidence, and reasoning. They make a claim, they look for the hard evidence, and if that evidence is solid, their reasoning dictates their very next action. Well, Python does the exact same thing.
To act like our detective, Python basically uses three primary keywords to handle these conditional execution paths: if, elif, and else. You always kick off your logic chain with an if statement. Then you can use elif, which by the way is a super handy shortcut for else if. Python uses this little trick to help us avoid excessive indentation and keep our code looking really clean. Finally, you can optionally wrap the whole thing up with an else statement.
All right, section 1, testing the evidence. Let's see exactly how Python checks the facts. And this brings us to a really foundational concept from the docs called truth value testing. According to the official Python documentation, any object, literally any object at all, can be tested for a truth value. Basically, Python checks the evidence by looking at whatever object you throw at it and deciding right then and there if it's considered true or false.
So, by default, Python basically considers an object to be true unless it falls into a few very specific categories of built-in false objects. We're talking about constants like none and false, any zero of a numeric type, like just the number 0 or 0.0, and, this is a big one, empty sequences or collections, like an empty string or an empty list. If the object isn't on this list of falsy things, Python just assumes the evidence points to true.
Moving right along to Section 2, Modeled Practice, we're going to trace the integer decision path.
Okay, let's dive into a source-backed worked example. First up, we use the input function to literally just ask the user to enter an integer. Whatever they type gets converted using int and then safely stored right into the variable x. So, our detective now has its raw data to work with. And here is our very first claim, if x less than 0. Python checks the evidence here. Is the integer less than 0? If the truth value testing comes back as true, Python executes its reasoning, which is the indented block of code right below it. It'll change x to 0 and print out a message. But if the evidence is false, Python is pretty lazy. It simply skips this block completely.
Now, what if that first if statement was false? Well, Python just checks our next claim using elif. It asks, elif x equals 0. If the user input was exactly 0, boom, this evaluates to true, and Python triggers the print statement to output the word 0.
And the cool thing is, we can just keep going. We can chain multiple elif statements together. Right here, Python checks elif x equals 1. But remember, the absolutely crucial rule here is that only one of these suites will actually be executed, specifically the very first one that evaluates to true. Once Python finds its solid evidence, it's done. It stops checking the rest.
Finally, we can wrap up the entire path with an optional else clause. You can really just think of else as your safety net. It safely catches absolutely anything that was proven false in all those previous conditions. Notice there's no condition needed for else. It's simply the final reasoning if all the other claims lacked evidence.
Next up is Section 3, Misconception check. Let's clear up some things about Boolean comparisons. So there's a really common mistake beginners make when checking Boolean values. Take a look at that wrong example, if greeting equals true. Now, while this might technically run without crashing, the official PEP 8 style guide, which is basically the strict ultimate rulebook for Python, tells us this is actually poor style. The correct Pythonic way is simply if greeting.
In fact, here is the exact quote straight from the PEP 8 programming recommendations. Don't compare Boolean values to true or false using double equals. Because of that truth value testing we learned about a minute ago, Python already knows exactly how to evaluate it. Writing clean, readable code means simply relying on the variable directly as the evidence itself.
All right, Section 4, Retrieval Check. Time to test our memory on empty sequences.
Okay, quiz time. Which is the correct way to check if a sequence, like a list or a string, is actually empty? Try to think back to our truth value testing list of built-in false objects. Based on that rule and the strict PEP 8 style guide, how exactly should we write this? Did you get it? The correct, fully PEP 8 endorsed way is simply if not seek. Writing if not len of seek is actually considered wrong by the style guide. Remember, empty sequences are already considered false by default. We really don't need to calculate their length to prove they're empty. We just let Python evaluate the sequence itself.
And that brings us to Section 5, the core lesson takeaway: claim, evidence, reasoning.
So if you take away just one thing from this explainer, it's that you should absolutely always think of Python logic as a claim, evidence, and reasoning path. The claim is laid out using your if, elif, and else structure. The evidence is checked automatically behind the scenes via truth value testing. And the reasoning? Well, that's just the execution of your specific indented block of code.
You now have the exact tools you need to dictate how your programs behave and react to real data. So, I'll leave you with this empowering little question for your next coding puzzle. What evidence will your next Python condition test? Keep practicing, keep testing those truth values, and have a fantastic time building your own logical paths.